Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. Today we're joined by Andrew Guldman, Vice President of Product Engineering and Research and Development at Fluid. Andrew and I caught up a while back to discuss Fluid XPS, a user experience built to help the casual shopper decide on the best product choices during online retail interactions. While XPS has expanded since we recorded this interview, we specifically discuss its origins as a product to assist outerwear retailer The North Face. In our conversation, we discussed their use of heat-sync algorithms and graph databases, their use of chat and other interfaces, and the challenges associated with staying on top of a constantly changing technology landscape. This was a fun interview. Before we jump into the episode, I'd like to join Pegasystems, this episode's sponsor, in inviting you to meet me this June at PegaWorld, the company's annual digital transformation conference, so that it optimizes every customer touchpoint on every channel in real time. That way, each interaction is relevant and timely to each individual customer, no matter if it's a sales call, a digital marketing campaign, or a customer service chat, either online or in store. And the system is always learning in real time to make the next interaction better. Pega's customers are the real stars at PegaWorld. There, you'll hear great stories of AI applied to the customer experience at real Pega customers. The event is a great way to learn from a who's who of the Fortune 500, and of course, I'll be there and speaking as well. To register, visit pegaworld.com and enter the promo code TWiML19 when you sign up. Again, that's TWiML19. It's as easy as that. Hope to see you there. And now, on to the show. All right, everyone, I am on the line with Andrew Guldman. Andrew is VP of Product Engineering and R&D at Fluid. Andrew, welcome to This Week in Machine Learning and AI.
Thank you very much. Great to be here.
So you've been at Fluid for about 18 years, not counting a brief hiatus that you can describe. But why don't you tell us about Fluid and the kind of work that you've done there over the past 18 years?
Great. Thank you. So in general, Fluid focuses on providing excellent user experience for online retail. And Fluid has agency and software as a service divisions. And within both of those address engineering, design, user experience, and strategy. Fluid's clients include The North Face, who I assume we'll be talking about shortly, Puma, Vans, Benefit Cosmetics, and many, many others, with offices in New York and in Oakland. So that's Fluid as a whole. My particular role at Fluid has been focused on engineering leadership. So I've worked in both the agency and software as a service sides of the business. For the last several years, I've worked primarily on two big projects. One of them, Fluid Configure, online product configuration platform, and the other XPS, which we'll talk about in more detail. XPS stands for Expert Personal Shopper, applying AI technology to online retail.
And XPS was a project that Fluid created for and with the North Face. Is that right?
Initially, yeah, they were our first customer with XPS. It's expanded a little beyond that, but they were the initial focus. Yeah.
Let's jump into that. Tell us about the general problem that you're trying to help these retailers solve.
Sure, absolutely. Well, first, just really brief encapsulation of the North Face, in case people are unfamiliar with them. They provide top quality gear that's really designed and targeted towards like climbers, runners, and skiers. And of course, a good jacket for runners is also great for hikers and is also good for lifestyle and so on. But they're really targeted towards technical, high quality gear. So what we were trying to do for the North Face, the genesis of XPS, was to help the more casual users figure out what to get from the North Face. The really technical, like the expert climber would probably know what they need in a jacket, but somebody who's going backpacking for the first time might not really know quite what to get. And so we wanted to help them sort of emulate the experience of working with a knowledgeable sales associate in a scalable online venue.
I can relate very personally to that need right now. I am in the process of planning my first bike packing trip, which is basically camping, but kind of carrying your gear on a bike. That's going to be later this month. And the array of stuff that the lists say that I need is immense. And then kind of sorting through all of the different options for each of the various components is just, there's a lot of work that one needs to do to, at least if you're like me and you want to kind of get the right thing. It's a lot of work. So I can definitely see why an online tool, in particular one that's powered by some element of AI, would be super helpful to folks.
Right, exactly.
So you're trying to build this tool. What does XPS provide? How does it kind of emulate this assistant? How does it emulate like a salesperson at a store?
In format, we adhere fairly closely to what would happen with a sales associate. You have a conversation, there's questions and answers going back and forth. And through that conversation, the sales associate is accumulating important information, Mm-hmm. And then as that information accumulates, that salesperson's recommendation gets better and better. So what that means in the more technical world of XPS is that we actually used graph database technology to represent we called them facts, just to be a fairly generic term that could be used to mean different things at different times, but like you'd have this directed acyclic graph of facts that could be hierarchical that eventually connected to products, and the edges in the graph had weight associated with them. So as a session with XPS proceeds, XPS would parse the responses from the user if they came in via free text, or it could also work with button clicks if the answers were a little more directed. But however they came in, it would result in weight being placed on nodes in the graph. And then the directed graph, we used a heat sink algorithm to accumulate weight on the products and thereby derive the recommendations.
What specifically is a heat sink algorithm?
So a heat sink algorithm, if you have, a directional graph where an acyclic graph where things point in a direction, just to look at a simple example without getting into hierarchy, you can consider product characteristics. So we're looking at North Face jackets, and you could say, okay, this jacket has color, right? So it can be red, or it could be blue, or it can be green, or whatever. So you'd have an association. Sometimes people would have color preferences. So you say you'd have an association, directed association from green to this particular jacket. So then if it comes out that I'm looking for a green jacket, I put weight on the green node in my session specifically. And then that weight traverses the edge of the graph and ends up on, it'd be multiple jackets that could be green, right? So green would be associated with an array of different jackets, all of which would receive weight from green. Then simultaneously, I'm looking for a waterproof jacket. So I put weight on waterproof. Waterproof is similarly associated with a collection of jackets. The weight it travels from waterproof to all of those waterproof jackets. So we have some jackets that have accumulated heat or weight from green, and others that have accumulated heat from waterproof. And so some jackets are hotter than others. The jackets that are both green and waterproof are the hottest ones.
Okay.
And so you have like multiple sources of heat, the nodes that have been activated. and then that heat accumulates on products.
Where does AI come in this project? What requirements did you have for artificial intelligence as you were building this out?
Well, the artificial intelligence requirements were pretty high level. The initial genesis of the product was a partnership between IBM and Fluid for the benefit of the North Face. So the original idea was to use Watson to create this technology, but that's pretty broad, right? So as we dug into implementing what I was describing there, the first attempt was just to use Watson as is. At the time, though, this is way back at the beginning of Watson. This was, a little bit after Watson had been used in the Jeopardy game show.
Okay.
Where it got a lot of notoriety there.
Right.
But at the time, it was a single API. It was this question and answer API that was really targeted towards the Jeopardy use case, where it didn't have the idea of context like I was describing, where you accumulate knowledge through a conversation. That really wasn't part of the game. And it also was designed to come back with a single answer. Because in Jeopardy, you don't say, oh, well, it could be this or that or that or that. It's just one answer. Right. And so the question and answer API didn't really fit our use case. So that was when we started getting into this graph database business. Okay. So in the context of the solution I was describing, we initially used AI technology for natural language processing to try to make sense out of the utterances that users would provide to us. That was the initial piece. What I was describing with the graph and everything was basically a content-based recommendation engine that really doesn't use a lot of sophisticated AI techniques. We'd always had in mind to get to machine learning, sort of collaborative filtering type techniques to improve the recommendations. But as of now, we're still waiting to get there. So it's been a little more focused on content-based recommendations.
The interface for XPS, is it a chat? I'm assuming it's a chatbot type of interface. And if so, are you using a platform technology to manage the chat interactions, parse out the intents and all that kind of stuff? Or are you doing that manually?
So at the highest level, it is a chat interface. And it's super compatible with things like Facebook Messenger. And we have implemented it on Facebook Messenger, but it doesn't require a dedicated chat platform like that. It runs just fine in a standard browser as well.
Right.
So it's pretty flexible in how it can be deployed. We initially, when we were building this out, the supporting technology to manage the conversation for us was not super satisfactory. So we sort of built our own deal. In the meantime, since then, we've evaluated other technologies like IBM Assistant, which do a lot of the same things that we've been doing and have a lot of advantages. Just the training capabilities they have, the ability to understand intents as well as entities, the ability to impact the behavior of the conversation, to change the flow of the conversation, have it work better without having to do any coding was really attractive.
Right.
So what we're sort of in the process now of incorporating Watson Assistant into XPS sort of as complementary pieces. If you want, I can go into a little more detail about how XPS guides a conversation relative to how Watson Assistant does. They have fundamentally different approaches, which can work well together.
Sure.
Head that direction? All right.
No, that's interesting because you mentioned using them in conjunction with one another, and I was starting to form a question around how that's going to work. So,
right. Okay. So, to start with Watson Assistant, I mean, there's a whole sort of family of technologies that operate in fairly similar ways. And they parse intents based on the intent that's been identified. You can parse out entities. And so you can do things, like customer service. It can understand that you're trying to track an order, could be your intent, for example. And then it can know that in order to track an order, it needs to have an order number, right? And so it can try to parse the order number from what you've said, or if it doesn't get it, it can solicit the order number. Once it has that, then it can move forward. And so you've got this sort of structure of intents with related entities. And it can guide a conversation that way. It can solicit what it needs based on what the intent is. So that's kind of the Watson assistant approach. XPS, on the other hand, is intended to be much more sort of directive and focused and purposeful and flexible in what it's doing. Like, its sole purpose is to recommend products. So you've got a potentially confusing collection of products, like all these jackets, so many jackets. There's like 20 kinds of ski jackets. What the hell, right? So there's all these products with the intention of recommending the right ones. And the Watson assistant approach tends to lead, the order in which information is solicited is somewhat fixed. If you're looking for an order, you get the order number. Whereas within the jacket recommendation world, there's a lot of different things that you could be soliciting. There's how it behaves in certain types of weather, how it does relative to wind and rain and temperature. There's color, there's breathability, on and on and on. Like, the number of questions that could potentially be asked is big. And if you ask them in the wrong order, it doesn't appear very intelligent. So one of probably our core challenge with XPS was guiding the dialogue in a way that would allow it to make the best recommendations the quickest. So we incorporated kind of taking that heat sink idea that I was talking about earlier, where you figure out what products to recommend based on the information you know. Mm-hmm. We kind of flipped that on its head and used like the complementary idea of hypothetically saying, well, if we knew this, how helpful would it be? If we knew that, how helpful would it be? Combining that with the natural collections, natural groupings of these facts. Like, if you're saying, like, is it good in mild wind or high wind or calm or whatever? If you're looking at the wind speed collection of facts,
right?
Well, that condenses nicely to a single question. You don't have to ask 3 separate questions. It's like, how windy is it going to be? And perhaps your answers are buttons if you want, or it could be free text, whatever you want, right? But if we've decided, based on analyzing all of these different facts and running them through these scenarios, we decide we care about wind is the most important thing to influence our recommendation. And we ask about wind. If we get to another point in a different conversation with a different user, maybe based on what they've told us, it's more important to ask about color to differentiate the candidate product set.
The way I would describe the algorithm that you're describing is along the lines of it's trying to maximize information gain per question asked or something like that.
Basically, the way that we phrase it is differentiating the candidate product set. Like, we have, based on what we currently know, we know that there's a set of products that are suitable. And what we really want to do with the next question is chop that set in half and be more confident about half of it. You know what I mean? So we kind of simplified the challenge to try to make it more consistent. And we found that taking that approach worked pretty well. So that's how we scored each one of these potential questions to ask. How much does it split the result set in half, and how much does it increase the confidence of one of those halves?
How complex is the algorithmic side of that? Is there a pre-existing algorithm that's known to solve that kind of problem, or did you have to kind of invent something from scratch?
We invented stuff.
Okay.
Yeah. We invented stuff. We were working. This was logic that ran in the graph database. We were using Tinkerpop APIs. It's
Tinkerpop
basic. Yeah.
APIs.
Yeah. I don't know where they came up with that name. It's standardizing the way that you can interact with graph databases. It's sort of like JDBC is to relational databases.
Okay.
Tinkerpop is to graph databases.
Okay.
So it's a set of standardized APIs. We were initially working with Neo4j, and then we moved over to Titan. The graph database space is quite volatile. So it was nice to have this sort of standard API to work with. But we were writing Java code that used Tinkerpop APIs to interact with the graph. It was sort of like streaming APIs, like if you work with Java collections and you start streaming them, and then you do one thing to them, and then you get a stream back and you need to do another thing to them, and you kind of chain these calls together. Just sort of typical sort of a Lambda type flow within Java.
Okay.
So it was, so you do things like you get your set of facts, and then you filter it based on the ones that have weight, and then you see where they point and what the edge weights are, and then you calculate the accumulated weight, and then you filter again. Anyway, all these sort of traversals and streaming stuff in Java. So yeah, we had to write this code. We basically would look at you take the original set of recommended products, then you'd apply hypothetical weight to a single fact, and then you'd see what the result of that was in this new result set, and then you just repeat that process for any of the facts that you could consider asking about, and then you just compare the sort of the weighting of the results, the recommended products, and see which one had the profile that most closely matched, chopping the original set in half and increasing its confidence.
And so was your product catalog space, or the intersection of your product catalog space and the characteristic space such that you could do that calculation all in real time, or did you have to pre-compute some of it? Or could you pre-compute some of it?
It was all real time.
Okay.
All real time. Yeah. The graph database ran quickly. I mean, that was one of the reasons we chose that technology. The traversals are really, really fast. And the accumulation of calculations as you navigate, as you traverse through the graph could happen really, really quickly too.
You built this algorithm that allows you to direct questioning in a way that helps a user kind of iterate as quickly as possible to a single product or a small set of products that they're interested in, but you still see their opportunities to use that in parallel with the Watson platform. How would those work together?
Yeah, good. That was what I was supposed to be describing before, right? So these different, like I was describing, these different mechanisms for driving a conversation. With Watson Assistant having this intent and entities approach versus what I was describing with XPS, and so the way they fit together nicely is that if the utterance can be if Watson Assistant can get some traction with the user's utterance, then you let it do its thing. So if it says, "Oh, this is customer service, I got this," then XPS isn't going to be able to handle that. That's not what XPS does.
Right.
And so if Watson Assistant was able to figure out that it could do something with it, then it does something with it. So Watson Assistant is kind of the initial recipient of the request. And then if Watson Assistant either identifies that it's something XPS could deal with, or it just doesn't know what the heck's going on, then XPS takes a cut at it.
Yeah, it sounds like if you walk into a store, there's a greeter there. That greeter is Watson Assistant. If you have a customer service question, they'll walk you over to the CS desk and kind of figure that out. But if you want to buy something, they'll kind of direct you to a salesperson, and that's XPS.
Exactly. Because what we found, I mean, this is pretty obvious if you think about it really, but when people come into like a chatbot experience, they don't all want to do what you want them to do. They're checking it out. They're like, oh, what is this thing? And XPS was really not very good at handling this broad array of things that were coming up. People just chatting. People, hi. And XPS didn't really know what to do with hi.
Right. I'm curious about the software development process and specifically the idea of incorporating in these, external AI-centric APIs and any ways that maybe you had to think differently about the development process, relative to other kinds of projects.
Well, I think the big difference is that the AI technologies we were using, like Watson Assistant, and to a lesser extent, some of the NLP stuff we were using, it's not like, talking to Weather Underground and getting back the weather. You know what I mean? Like you have to train them, you have to prep them up, so there was this body of work that typically is best handled by experts to get the corpus, to get the service ready to do what we needed it to do. And just needing that different skill set definitely presented challenges for us. Our team was really a team of software engineers. and the idea of using APIs at runtime was super comfortable. But the idea of needing to train a service so that it would recognize certain intents was pretty foreign. And just because of staffing challenges, the engineers typically had to kind of step into that role of training these systems.
And so did you have to build out specific processes and tooling to enable that to be done successfully?
I don't know if it was really that formal. It was basically like people were obligated to do it, and so they did it. And as they did it, they got better at it. The tooling was already present. Like there's Watson Knowledge Studio comes as part of the package, which is great tooling, sophisticated at this point. It's mature, works really well. So we fortunately didn't have to address that part of the puzzle. Mm-hmm. I mean, we played around at different times with just manually using Watson Knowledge Studio to do the training versus trying to do it via APIs, and we hit our heads on walls every once in a while when we would try to do our own automation. It's generally worked better to like do it the way they sort of want you to do it.
Which is more manually or less?
More. Yeah, it's actually a little bit more manually in the case of WKS, the Watson Knowledge Studio.
Okay.
It was easier to just go into their UI and do their thing. I mean, that's continually progressing, mm-hmm. which actually I think is another way that this type of work was a little different than the work that we were accustomed to doing.
In what sense?
Well, like just this exact thing you were talking about, like trying to interact programmatically with some of these services would change. It would change way more quickly than we were accustomed to. There'd be new vendors offering things that were better from one week to the next. WKS would have a big iteration and things would change around, and things that weren't possible previously were now possible. There'd be discontinued products like Watson Assistant went from being Watson Dialogue to Watson Conversation to Watson Assistant. And through each step of that, there were major changes. So it's just such a booming and alive field. Mm-hmm. Sometimes it just felt like the ground was constantly shifting under us. And so we had to incorporate into our normal development process this idea of sort of continually having spikes where we were doing research about things that we had already researched. There had to be kind of a lot more time and energy put into staying abreast with the current technologies. And we also incorporated really short sprints. We were on a weekly sprint cycle on this project.
Okay.
Throughout its whole life cycle. At the beginning, we thought it was going to be a temporarily short sprint cycle. but we found that we continuously were needing to like adjust course. We'd learn something new, we'd get some new feedbacks, there'd be some new technology, and we're continually just kind of, I don't want to say zigzagging because we were generally pointing in the same direction. There'd be significant, adjustments to the approach almost on a weekly basis.
Mm-hmm. Yeah, but at the same time, it sounds like you were able to successfully get this done with a traditional engineering team, whereas if you were, needing to build all of the AI, NLP, conversational bits from scratch, it may have been a bit harder.
Yeah, absolutely. Yeah. And the degree of maturation in the space that we saw in the, couple of years we spent building it was just amazing.
Mm-hmm.
It would have been awesome if could have been at the place it is now 2 years ago. It would have made our lives a lot easier, but we, perhaps gained a deeper appreciation of the advances.
How did you address like the testing part of the development cycle and understanding, did you try to create some kind of regression testing for the training process so you knew if you kind of broke something in training, that kind of thing?
Right. Great question.
Again, kind of mapping this, traditional dev process to this, AI enhanced, let's say, dev process.
Yeah. I'm afraid my answer is going to be a little bit of a cop-out here. We were looking at this, finding the right balance between delivering stuff quickly for a small number of customers in this constantly shifting space versus having a solution that was really solid and scalable and we'd be able to use for 50 customers. There was this real tension between that. And as you say, it's directly attributable to applying sort of traditional web software development, multi-tenant software as a service practices to this AI space. So, we just kind of did the best we could. We had thorough regression tests around the more traditional parts of our code base. We had thorough unit tests and test coverage metrics and all that kind of stuff around the Express application and around our React front ends and stuff like that. When it came to the Watson Assistant pieces and the NLP training, it was a little softer. It was a little softer. We're intending to button that up a little better as we move forward, and we're expecting, given the pace of evolution of the tools, we're expecting that it's going to be easier to do that going forward.
Mm-hmm.
As tools like Watson Knowledge Studio advance, we're expecting to be able to script the training more thoroughly,
right,
and tie that scripted training to testing the results of it more thoroughly. But it's really tricky because not only is potentially our training set changing, but also, like Watson Assistant is a service we're relying on that's constantly evolving. So it could be that our training data stays the same, but the results change, even though we didn't change anything.
Mm-hmm.
And so we didn't get too obsessed with buttoning that up at this point in the process.
Right.
I've embraced the chaos to a certain extent. And I think an important sort of corollary to that is that, we're not sending rockets into space, right? And we're not automating $1 million trading, right? We're recommending jackets. And so we kind of leveled the appropriate appetite for risk with the domain. If something goes awry with the training of Watson Assistant and it's not quite right, well, we can tolerate that.
Mm-hmm. Mm-hmm.
So, we do our best.
Mm-hmm. Where did the training data come from?
We have thorough analytics built into XPS so that we keep track of every step of every user's interaction with the service. And we're able to use the utterances that we captured from users throughout the process. So there's a manual step to it, in that the taking the data from our analytics system and feeding it in to Watson Knowledge Studio, there was some manual processing involved with it, especially around the ground truth. Like we could have automated feeding in all the utterances, but it would have been a little trickier to say what the correct responses should have been. But we did have the advantage of accumulating a large amount of real data and being able to use that throughout the process.
Mm-hmm. And from the perspective of the engineers that were working on this, what was their experience like? Did they feel like they had to become data scientists in order to be successful with this project? Or, was there a good balance between the APIs taking care of the deep algorithmic bits and them, doing the higher level training stuff, the integration and the traditional engineering tasks?
Yeah, good question. There was, on the one hand, the engineering team were somewhat generalists who really enjoyed being exposed to new ideas and new technologies. Mm-hmm. So like in the course of this project, some of the people on the team were learning React and Redux for the first time, for example.
Okay.
And the entire team was learning about the Watson APIs for the first time. And so being exposed to new technologies like that was awesome. And I think there's just the idea of understanding and being exposed to the role of a data scientist and how that compares to software engineering, and being in a situation where they were forced to kind of be a little bit more immersed in that data science role than they ordinarily would have been. I think that broadened horizons and was welcomed. But at the same time, I think there were kind of, they reached kind of a saturation point where like having to deal with the fact that it wasn't, recognizing, the difference between, what are some examples of these things? There's certain utterances that just cause problems. Like, just like negation is a simple one. I want a jacket that's not green, or you could say that anything but green. And recognizing these negations correctly can involve some extensive training. Some of the language around that is fairly ambiguous to the untrained NLP system. Mm-hmm, mm-hmm. And so like having to go back in and like, oh God, anything but green. Why isn't that working? How are we going to train that? Like that wasn't generally the developer's favorite part of the job,
Okay. Yeah.
So I think at the abstract level, the idea of understanding data science and how that fits into the process and how these AI technologies really work was awesome. And they loved it, but they kind of had enough after a while.
Okay. And kind of end of the day, how was the project received from the North Face's perspective, the customer perspective?
Well, it was certainly understood from the get-go that this was kind of bleeding edge stuff, that we were figuring this out on the fly and giving it a go. So the format and the vision of it, I think was awesome. They really liked that. One of the challenges that we met with the North Face that honestly surprised me was the product attribution turned out to be surprisingly challenging. I had assumed that the North Face would have really thorough, faceted characteristics of their jackets that would provide us with all the raw material that we would need in order to differentiate them through a conversation. But we found two challenges of that. One is that the existing faceted search capability that you see, basically across the e-commerce landscape is really good. Like if you want to just sort of check boxes and say, I need a jacket that's waterproof, I need a jacket that's green, like you don't need this conversational interface to do that. You can just click, see it. You know what I mean? Right? It's like, so that is
I am so surprised you said it's really good, because in my head, as you were saying that, I was thinking is really horrible.
Well, I guess in some places it's implemented better than others is probably the best way to say that. I mean, I think of like kayak.com, when you're searching for flights or hotels or something, and like, to me, that's awesome. Just, it's really nice. Like, but you're absolutely, of course, you're right. I mean, it's not implemented well across the board. But the idea has been articulated successfully in certain cases. And so we deliberately did not want this conversational experience to be perceived as like a watered down version of a faceted search.
Right.
And so part of that sort of necessitated that we have facets, we have product attributes that are different, they're kind of qualitatively different. And so we started looking, experimented around with different things, like more emotional type attributes where you'd say like, I want an adventurous jacket. Well, like, what does that even mean? On one hand, but if you could somehow capture that and kind of represent that, or, like the personality of the shopper could translate into like finding jackets that match that personality, whether it's adventurous or studious or whatever it may be, so we spent some time kind of exploring that in order to really maximize the conversational benefits. And that proved to be difficult. I can't say we hit it out of the park with that piece. Mm-hmm. So there's clearly room for more progress, like identifying how to make this more satisfyingly conversational and how to obtain the product attribution necessary to do that.
Are the challenges that you had with regard to the product attributes specific to these more emotional attributes that you were looking for, or even some of the traditional attributes as well, like the kind of the, did you deal with challenges in just having the basic kinds of information you'd want to help customers make decisions?
Yes, for sure. Take waterproofness, for example. Like, if you don't think about it too much, it seems really straightforward. The jacket's waterproof or it's not, right? But it's not that simple. And there are some fairly formally defined standards of waterproofness. Mm-hmm. You have water resistance versus waterproofness. And so you have the one challenge of like the interface with the human being, with the person who's buying this thing.
Right.
And like we're trying to avoid jargon, but it was surprisingly difficult to avoid jargon. Same thing with windproofness, wind resistance and all that. So you've got kind of this sort of impedance mismatch between the technical characteristics of the jackets and the way a user might perceive them. Mm-hmm. And then sometimes too, there was just missing data. You would think that it would just all be there, but it's not, like the systems that they use, sometimes all the dots don't connect all the way out to where we got the data. So it got to be sometimes a bit of a bottleneck, just getting data that they just must have, but it wasn't flowing to us.
And how did you address that?
Well, the scale that we were looking at with the North Face is relatively small. We got a few hundred jackets. So we would just we were just working with the North Face product team and just working with people there, and they help us resolve things that are missing. That's sort of the simple part. It's cumbersome, it's not super ideal, and it raises questions around scalability, like it's working okay because we got 300 some odd jackets, but if we were to expand, that would be more problematic. Mm-hmm. With other customers we've worked with, we've had larger numbers of products, which has made those problems more real, and we've had to we've leveraged. This is actually another place where machine learning has come in, where you get the information that you have about a product, things like its description and so on, mm-hmm. can be used via machine learning to perform classifications and determine some of its attributes. Mm-hmm. It's limited, it depends on what kind of description you have for that product as to how well that will work, or if you're able to tap into supplementary sources like product reviews.
Right.
But it's helpful, but it doesn't truly solve the problem. We've also looked at crowdsourcing to help with it too.
Mm-hmm.
But it's just definitely a challenge. It really kind of opened my eyes to like a whole industry. I didn't really quite realize that there's like a whole industry around product attribution, and it's tricky.
Mm-hmm. Mm-hmm. It's amazing. So some years back or at some point, someone used some attributes to come up with a description, but you've lost connection to the attributes themselves and have to like infer them using ML from the descriptions that they wrote.
Basically, that's sort of what it seemed like. Yeah. Yep.
Wow.
Yep.
And so this system is like, it's up on the northface.com/XPS. How do you see it evolving over time? You talked a little bit about, some areas, but where does it go from here?
What's the budget? I think that probably the most interesting place for it to go is machine learning. Mm-hmm. So we've got that whole heat sink business I was talking about to provide content-based recommendations.
Right.
But I see using machine learning in two ways to benefit the system. One is to help figure out which question to ask next. So you could be seeing, based on the characteristics of a session in XPS, mm-hmm. you could see which questions, not based on this predictive stuff we've been doing, but you could just see based on like actual results of prior sessions, which questions delivered the most value.
Right.
And then, of course, you could also be using it to actually provide product recommendations. You could see, okay, based on how this session is progressing, what products received positive feedback from similar sessions in the past, and then bump those recommendations up. Mm-hmm. And like I had mentioned, the analytics tracking that we've been doing, it came up when we were talking about like training the NLP system. Well, that analytics system also will provide us with training data for both of those applications of machine learning. Mm-hmm. So we're positioned to make that happen, but all you have to do is listen to a couple of episodes of TWiML to understand that that's a piece of work. But I think that would be a great place for XPS to expand.
Andrew, thanks so much for taking the time to chat with us about this project. It sounds like a ton of fun, and I'm looking forward to playing around with it and maybe seeing if I can find a jacket.
Yeah. And hopefully we can expand to give you advice about bike panniers and tents and stuff too. Well, thanks a lot, Sam.
Thanks, Andrew.
All right, everyone, that's our show for today. For more information on Andrew or any of the topics covered in this show, visit TWiMLAI.com/talk/239. As always, thanks so much for listening, and catch you next time.